Welcome to Section 2, where we'll be discussing advanced language features and functional concepts. In the previous section, we reviewed some of the many great features in Swift. We also introduced the concept of functional programming, which we'll be exploring more in this section. In this section, we'll be constructing a classic programming tradition called Game of Life. As we progress through our build, we'll discuss closures, extensions, generics, higher-order functions, and finally, sequences and generators. Now, we move on to the first video of this section, introducing Game of Life. In this video, we're going to go over the application we'll be building by explaining the origins and the rules. We'll then begin laying out the necessary boilerplate code. At the end of this video, we'll be able to run our application. Although this course is not intended to be an iOS development course, I have found it best to convey new concepts both conceptually and in the context of a real-world application. So we'll be utilizing this Game of Life application as we cover each topic, but keep in mind that the focus is on the Swift language. The application is just a byproduct. Game of Life is a traditional programming exercise, which some would go as far as to call the advanced version of Hello World. It's a cellular automaton devised by British mathematician John Horton Conway in 1970. A cellular automaton consists of a regular grid of cells, each in one of a finite number of states, such as on and off. In our case, pre-birth, living, and dead. Game of Life has been rehashed many times and in various programming languages, including JavaScript, Ruby, Scala, C, C#, and the list goes on. Of course, we can find many different versions written in Swift. Most are written, however, using the object-oriented approach. We'll be using a functional approach with our game, inspired by Colin Eberhardt's rendition, which looks very similar to what one might find in both Scala and Haskell versions. You can find a link to Colin's version of the game in this video's resource page, or just visit scottlogic.com, where he maintains a fantastic blog. We'll begin by building a non-optimal performing version of Game of Life, and throughout this course, we'll measure and test our code's performance, replacing bits and pieces until we end up with a much more efficient version of the game. Although we will be using Game of Life for many of our exercises throughout this course, we'll also be working with many simple demo applications depending on whether the exercise fits into the Game of Life ecosystem or not. So here's how the game works. Every cell will interact with each of its 8 surrounding neighbors. These are the cells that are horizontally, vertically, or diagonally adjacent. At each evolution cycle, the following calculations will run. 1. Any living cell with fewer than 2 live neighbors dies. 2. Any living cell with 2 or 3 living neighbors lives on to the next cycle. 3. Any living cell with more than 3 living neighbors dies. And 4. Any dead cell with exactly 3 live neighbors becomes a live cell again. So, now that we know what we're building, let's get started with the boilerplate code. Now, much of the code we're going to be writing in this particular video is either off topic because it has to do with core animation, or is specific to iOS development, or it's something that we already touched on in Section 1. So, having said that, we'll go through this setup phase rather quickly. But don't worry, the rest of this course will be step by step. Let's open up Xcode and create a new project. Select Single View Application, and then click Next. We'll choose Game of Life for this project name, and make sure that Swift is selected for the language and iPhone for the device. Finally, we'll make sure that Include Unit Test box is checked. We'll be utilizing unit tests to measure the performance of our code later in this course. Click Next and select a save destination. We'll begin by adding the necessary code files to our project. To add a new file, we can either Control-click or right-click on the project's parent group and select New File. Alternatively, we can create a new file by clicking inside our project navigator and pressing Command-N. In the left pane, we'll select iOS and then Source. Then we'll choose Swift File and then select Next. We'll name this file State and click Create. Here, we'll create the possible states for our cell class, which we'll create next. Create an enum, name it State, and give it a type of int so we can associate raw integer values with our enum. Finally, we'll define 3 cases in line, giving the first case the value of 0. Remember, the compiler will infer the values for all subsequent cases. We'll also add a static function named randomState that will randomly select a state for us. This will come in handy while initializing cells. Next, we'll write our cell class. Press Command-N and create a new file. Select iOS source and then choose Swift file and click Next. We'll go ahead and name this file cell and click Create. We'll create a simple class definition for our cell and we'll add 3 properties: an x-coordinate, a y-coordinate, and a state. We'll also add an initializer, which I'll paste in now. So we see that our initializer takes 2 integers, which represents an x and y value. And then we utilize our randomState function we declared a moment ago to set a random state. This does it for our cell class. Let's add another file to represent our cell's life cycle. Press Command-N, select Swift file, and then click Next. We'll name our file Life and click Create. We'll start by adding a simple class definition for Life, and we'll add 2 properties to it. Our first property we'll name Cell, which will hold an array of cell. And our next property we'll call Grid Size, which will define the size of our grid as an integer. We'll give it a value of 20 for a grid with 400 cells. Since we want to supply a grid of cells when our Life class is instantiated, we'll need to add an initializer which will do some work for us. We'll define an initializer that takes no parameters and contains a nested loop that populates our grid. We're going to come back to this later. Next, let's create a new Cocoa class by pressing Command-N and choosing iOS, Source, Cocoa Touch class, and then click Next. We'll name our file GameBoard and make it a subclass of UIView. This class will be responsible for drawing our game for us. We'll add a constant that'll hold an instance of our Life class. We'll create a simple initializer that takes a Life object as its parameter and assign it to our Life variable. Let's uncomment drawRect since we'll be using it to draw our game. Next, we'll add our required initializer. For brevity, I'm going to go ahead and paste the drawing code in since core animation is not directly related to the subject at hand. So we've created a UI graphics getCurrentContext object, and a color4cell function utilizes enum switching to set the color of each cell based on its state. We've added a frameForCell function that returns a CGRectMake with the dimensions for each cell. Finally, we loop through our cells and put our 2 methods to work. Finishing up with our initial setup, let's go to our main.storyboard and add a view. Search for View in the Object Library and scroll to the bottom to find View. We'll drag a view out onto our view controller, position it, and then, with a view selected, click the Resolve Auto Layout Issues button and select Add Missing Constraints. Next, we'll show the Assistant Editor and Control-drag a connection from the new view to its view controller, creating an outlet for your view. Name it Board View. We'll add another variable named Life at the top of the view controller, which will hold an instance of our Life class. And then we'll create a variable named GameBoard, which will be of type GameBoard. Now, add a simple required initializer to initialize our GameBoard. Next, we'll add some simple initialization to our ViewDidLoad. What we're doing here is setting our GameBoard's frame equal to our board view, and then we're specifying where the center of our GameBoard view is. Finally, we add our GameBoard to the board view, which displays our grid in our view controller. Build and run, and you should see an entire board of cells in random states. In this video, we introduced Game of Life and set up our initial code. In the next video, we'll begin by adding our game logic. Along the way, we'll introduce and discuss closure syntax and functional value types.